All right, everyone. Let's run through Part B of the final exam review. This would be, again, we did the first two pages, pages 1 and 2, and now on the sheet that you have, you'll have it scrolling too in the video. This will be the start of page 3. Let me do pages 3 and 4 of all 6. So we've done pages 1 and 2. Now we're going to do pages 3 and 4. I'll try to go at a decent pace, see what we can do about this. What they are asking for this one, they said round it to the nearest whole number, find the area of this figure. We'll find the area of the rectangle and add it to the area of the triangle. Find the area of the rectangle, find the area of the triangle, and add them together. What you have here for a total area, and we start with chapter 7 on this thing, is you've got a height of 21.5. That's feet. And you've got a height of 21.5 and a length down here of 28.5. That's for the rectangle. For the triangle, it's going to be 1/2 base. The base is going to be 27.5 times height. Well, I kind of ran out of room a little bit here, guys. It comes right around here. And the height is also 21.5 because they have the symmetry here that we have. You add these together, you are going to have the total area. They want you to round it to the nearest whole number, so let's see how the whole thing plays out. What we have here is the 21.5 times 28.5. Uh, 21.5 times 28.5 plus 1/2 times 27.5 times 21.5. 908.375. 908.375 square feet. That's it. They want that rounded to the nearest whole number. So, absolutely. So what that's going to be is 908 square feet, right? Because the 3 doesn't do too much. So there you go, guys. So you take that. We got that answer. And for the area. Fantastic. We have there, guys. Over here, they're asking for the volume of this figure. And the way they're saying it, also round it to a whole number. Well, this is a cylinder. The volume of a cylinder is, as we've said before, is pi r squared times h. V is pi 3.1415926. The radius, well, this is the thickness of it, or the diameter of it. The radius is half of this, which is 1.635. If you actually take half of that and you square that. The height, well, in this case, the height is the length, and that's 46.5. Well, I mean, there's a lot there, but not too bad, not too unreasonable. What we can say here is, see if there is a pi anywhere. I could have sworn there was a pi. I'm sure it's there, and I'm just not seeing it. So let's not even worry about it. Let's go 3.1415926 times 1.635 squared times 46.5. I got 390.5156. .5156, I guess you could say. Centimeters. They have meters on here. Tell me they did not have meters. Did they put, no, they got centimeters, okay. Centimeters all over the place. If it was meters, we'd have a lot to say. I'm sorry, forgive me. That should have been centimeters. This is going to be cubic centimeters. Round that to the nearest whole number. Is that going to stay at 0 or go up to a 1? It's going to go up to a 1. So it's going to be 351. $391 rather. I'm sorry. Let me see here. Yeah, I'm sorry. Remember, it was 390.5156 centimeters cubed. Is that 0 going to stay at 0 or go up to a 1? It's going to go up to 1. It's 391. I'm sorry. So that's pretty good too. .391 cubic centimeters. 391 cubic centimeters. So let's see what we got here, guys. What we're talking about here is give an answer. Well, make a long story short, this is Al meaning aluminum. The density, the weight density, I'm being a little somewhat cavalier with the language that gets used. Usually rho is associated with mass density, not weight density. But let's, for the sake of the mathematics that they're trying to discuss, the mass is going to be the density times the volume. The density is 0.0924. The volume, they said rectangular box. Rectangular box is associated with length times width times height. So at that point, 36 times 32, 36 times 32 times 0.138, fantastic, 158.976. There it is. What's the mass going to be? Well, let's figure it out. 158.976, that's the volume, 158.976 times the density, which is 0.0924, just what we have here, 14.6894. 14.6894 pounds. LB for pounds, or you just write out pounds. That's fine. The answer they're asking for here is round to tenths. Is that going to stay a 6 or go up to a 7? .7 pounds, or LB. Mass is 14.7 pounds, or, I said mass. Better way to write that, I mean, that's usually the way it's written. Let's kind of give a little more specificity to this. The mathematics is essentially, for our purposes, identical. The weight is this, the weight is that. We'll talk about weight density in regard to rho right there, the Greek letter rho. The weight will be 14.7 pounds. Let's see where that is. £14.7, LB. They wrote LB there, that's fine. 14.7 pounds, absolutely. That's the case, let's keep going. They want you to add these two. Every 60 seconds gives you a minute. Every 60 seconds gives you a minute. Every 60 minutes gives you a degree. Let's go. You add these together, you got 67 seconds. 67 seconds, huh? You add these together, you got 67 seconds. I'll just use 7 of those seconds and put 60 seconds up here, which is 1 minute. 1 minute added with this is 8. 8, and here is 6. It's 68. 68, I'll give the 8 minutes here, and 60 minutes I'll take over here and make it into a degree. Add these together, and you end up getting 26 degrees. And that's where you want to go with that. You're carrying stuff off. As soon as you reach 60, boom, you put 1 over here. As soon as you reach 60, you put 1 over here. However many groups of 60 you reach, every time you reach 60 seconds, it's 1 minute. Every time you reach 60 minutes, it's 1 degree. And that's the way you play it. Here we can borrow a little bit if we can. Let's borrow from the 18 degrees and make them 17 degrees. Well, where did that 1 degree go? 1 degree is 60 minutes. I'll leave it right here, and maybe that'll be enough for me. 42 seconds minus 25 seconds is 17 seconds. That's okay. That works. 60 and 15 is 75. 75 take away 52 is 23. 17 minus 7 is 10. Sounds good. Make sure you're borrowing. Make sure you're remembering. Every 1 degree is 60 minutes. Every 1 minute is 60 seconds in all these instances. So do the borrowing and all other lending that takes place here, do it appropriately. Just make sure we got it right, guys. Right. Let's see what we got here. Number 4, yeah. That's 26 degrees, 8 minutes. 26 degrees, 8 minutes, 7 seconds. 10 degrees, 23 minutes, 17 seconds. For number 6, really quickly, it's hard to actually draw this one. It is a rendition of 3-dimensional space, and they want you to say what the point is that's being described. So what they're saying on this one is, what they're saying on this one is, for number 6, there's something doing this, then this, then this, and you're going this way. Well, this is going into the negative realm this way. 1, 2, 3. And then there is, then there's this guy going this way in the y direction. So this is z, this is x, this is y. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's 5 this way, 3 this way, and you're going up this way, also 5. 1, 2, 3, 4, 5 for this guy right here. This is, to me, there's almost no good way to draw this, but you're going, this is positive x direction coming out at us. Positive x direction coming out of us. So it's a negative 3 this way, a positive 5 that way, and a positive 5 straight up. So what do we got here? We got basically, when we're talking about it that way, x comma y comma z is equal to the x is negative 3, the y is 5, and the z is 5. And that's basically the way they're trying to go with that. It's a lot easier when you look at what I have scrolling at the end of the video. You can visualize it a lot easier than what I got right here. So get rid of that. Negative 3 comma 5 comma x comma y comma z is negative 3 comma 5 comma 5. If I could visualize it. Yeah, right. Negative, there it is. Negative 3 comma 5 comma 5. Okay, very good. Fantastic. That is page 3. That completes page 3, you guys. I might have to take a pause on this thing and come back, but let's try to nail a couple of these. Let's get them all under control and get it done as soon as we possibly can. Pause this 1 second. Okay, guys, welcome back a little bit. Let's take a look at some of this stuff. They want these in fractions without any fractions within the fractions. Here we have fractions within fractions. We have a fraction of fractions. They don't want anything like that here. The way you can kind of look at that is play the following. You could take the one right here. The one right here is the same as r divided by r. That's the same as 1. At that point, you got v over r minus, v over r divided by, what's r over r minus v over r? You've got a common denominator, then it's just r minus v. If that's the case, put parentheses here. A fraction divided by another fraction is the first fraction left alone multiplied by the reciprocal of the second fraction doing the dividing. That's pretty interesting. The r's cancel. At the end of the day, you've got v over the quantity r minus v. You don't have to have those parentheses there. I always put them there. You know that. You guys know that by now. But this is the final answer. So that's that. V over the quantity r minus v will make that work. Same kind of argument here. Got a lot going on here. I don't know how I'm going to pull this one off. Well, what's a times b? A times b is ab. So I need ab to be on the bottom of both. I'll tell you what, I'll go a over a, special one right here, to multiply with that, and I'll go b over b, special one over here, to multiply with that. The 1 is the same as a divided by a, and that gives me a common denominator. Let's see what we got here. B times 1 is b. B times a is ba or ab. That doesn't matter too much. 1 times a is a. B times a is ba or same as ab. Let's talk about that. And we've got this. We got a common denominator here. Well, I'll tell you what. Let's leave it for a second. Let me keep it like that for now. Kind of keep looking at it. This right here, common denominator, is b plus a over ab. This right here is a plus b over a. Well, look, guys, I don't want to beat this thing up too badly, but b plus a is the same as a plus b. You'll see why I'm doing that in a second. This is ab. That's right, that right there. This is a plus b. Put it in parentheses. Over a. a fraction divided by another fraction is the first fraction left alone. The first fraction left alone multiplied by the reciprocal of the second fraction doing the dividing. That entire quantity and that entire quantity cancel. The A goes into here. 1 times 1 is 1. 1 times B times 1 is B. And that's that. At the end of that whole song and dance, this is what it is. For this one right here, for problem number 2. Okay? The other one had, so let's just look at those really quick. V over R minus V and 1 over B. The one before that, number 1, was V over R minus V. V over the quantity R minus V. And 2 is 1 over B. What about 3? Well, see what else we can say. 4 cancels into 8 twice. T cancels into t squared t times. 5 cancels into 25 5 times. S cancels into s cubed s squared times. 1 times 1 times 2 times 1. 1 times 1 times 2 times 1 is 2. 1 times t times 5 times s squared. 5 s squared t. Let's make sure that should be it. Two over the quantity 5s squared t. There it is. So 1, 2, 3, we got them. 1, like I said, I already had erased it, but I'm confident that's the right answer. There shouldn't be any problem here with that. Let's see what we actually have here, guys, when we're looking at that. Yeah, absolutely. When you're looking at that, it's yeah. We said it was going to be for number 1. We said it was going to be V over the quantity. We said that it was going to be V over the quantity R minus V, and that's what they have. Shouldn't be any kind of problem there. And everything else kind of worked out too. Right, V over the quantity R minus V. Very good, fantastic. For number 9, let's take a look at that as well. They say solve for D and solve for K respectively when you're doing these guys. So let's take a look at that. So to solve for D, you guys, there's a lot going on here. I mean, I would probably, looking at this, there's a number of ways to go here. Let me probably get myself a little bit of room. Solve for D, huh? Yeah. I mean, let's take a shot at it. The way I'd look at it, and I'd say we can always erase and go around stuff. Try to get everything like from this vertical stuff, get it to be more or less horizontal. H is the same as H over 1. I can put parentheses right here. Let me do that. Let me do that. Let's see what happens. 1 times the quantity R minus D is the quantity R minus D. I'll deal with that in a little bit. H times the quantity, A, again, you don't distribute here. You can distribute at some point over here, or you can leave it as is. This acts like it's an actual single entity. And with multiplication, you can go this guy into here, or you can go this guy into here. And then from there, do something else. I mean, this is a little weird. You could take HA and actually get them into both here, but that's, because it's a straight out multiplication, all of this can hit each of those. You gotta be, let's just watch out. Let's just watch out when we're doing this stuff. They want you to solve for D, I guess. Well, let's get D over to one side. We got a lot to do. Let's go here. Let's go here. This is HAR plus HAD. Okay. This is R minus D. Minus D, this is 1R. This is 1D. Minus 1D is plus a negative 1D. If you allow me to say that. Let me get HAD on each side, or however you want to do it. We can do this a bunch of ways, actually. But we're trying to solve for D. Tell you what, let me add a positive. This is not the only way to do this, obviously. Let me add a positive 1D on each side. That's out of there. You end up getting one R. So you added 1D. You added 1D on each side. You saw me do it. HAR plus HAD plus 1D. HAR plus HAD plus 1D. It's good to put a 1 in front of the D. Because when you're doing factorizations, you've got to account for the fact that the D means 1 times D. There's 1D there. And you'll see what I'm talking about in a second. If you take this and subtract HAR on each side, you got 1R minus HAR. We'll cross every bridge as we need to. That's out of there. You got HAD plus 1D. All right, this is pretty interesting. There's a lot going on here. There's just a lot going on here. Tell you what I'm going to do. I don't know what to do at this point. I mean, I don't know exactly where I want to go with this. I guess I could pull an R out of here. 1 minus HA. If I pull an R out of here, if I pull an R out of there, it's 1 minus HA. If I pull a D out of here, if I pull a D out of there, it's DHA plus 1. That's significant. The other stuff maybe not as significant. But what we have here is what we have here. I mean, let me on each side, I got to solve for D. And again, there might be a number of ways this can be written. I don't think, I mean, if we're strong enough to get to here, I'm certainly not going to nickel and dime anybody on that. HA plus 1 or 1 plus HA. This goes D equals R times 1 minus HA over 1 plus HA. I thought maybe there's going to be another cancellation. No dice. This is it. You can multiply this out and write it like D is equal. You'll multiply this out, get R minus HAR or ARH, things of that nature. And here 1 plus HA or 1 plus AH. Nobody's going to nickel and dime me on that, guys. Just make sure we got the right. I mean, I'm not going to. This frequently is going to be allowed to be the last answer on this. This is relatively involved enough that we really should take a look at it. One or the other, each of these mean the same thing as the other. Each one of these means the same thing as the other. Let's see what that is. And that was, again, chapter 1, number 1, solve for D. From chapter 9, forgive me, chapter 9, number 1, solve for D. And there you go. They write it a little differently than I do. They write it R minus A. They write it R minus AHR. R minus AHR over 1 plus AH. Doesn't matter the order. I wrote it like this. That doesn't matter. That doesn't matter. Both of these are fine. They're pointing to the same answer mathematically. I've seen people, they like to have the stuff, factored out. This is actually a little easier to visualize than that, if you ask me. But, okay, either one's fine on that. That was number 9. Number 9, number 1. Or chapter 9, number 1, I guess you could say. Chapter 9, number 1. Let's look at chapter 9, number 2, and see where that is going to go. So, very interesting regarding this whole thing. So, let's keep going. Okay, I mean, it's the same argument here. Solve for K. There's a number of ways to go. This is going to go a little bit easier, actually, guys, to be honest with you. Subtract the H on each side. And, that's going to go. And you got K times the quantity, W minus 1. They already kind of made that easy for us. You subtract H on each side. And it's V. I don't know how big the V was made, guys. I've got to look at it. Yeah, it's a small V. So I'm going to subtract the H on each side. That's gone, and that's what's left. So I wrote it here on the left-hand side. V minus H is going to be this. Put parentheses right here. When you do that, guys, just take W minus 1 on each side. V minus H, W minus 1. They don't put parentheses usually. I'm doing it. That's not a big deal. That's just make sure the answer is, at the end of the day, K equals V minus H over W minus 1. So we got that. Let's take a look at that. That was problem number 2 from chapter 9. So what are we saying here? We're saying V minus H over W minus 1. Let's see what we got. Yeah, V minus H over W minus 1. Okay. Looking good. Looking pretty good, you guys. Let me keep looking at this thing. Don't know how much time I got, but we're definitely going to get through this. Forgive me. Let me just pause this for a second, and I'll jump right back in again, as we usually do. Okay, guys, let's keep going. There's some more, problems to look at here. Let's see what we can say about it, and we'll proceed. Let me get a little more chalk here, I think. All right, guys. For the Chapter 10 content, we're still in Part B. Review for the final exam. Review for the final exam, Part B. Let's see what we can say here. Find the slope of the line through these 2 points. Well, the x sub 2 is going to be negative 4. The x sub 1 is going to be 2. The y sub 2 is going to be 2. The y sub 1 is going to be negative 4. The slope is y sub 2, this guy, which is 2, minus y sub 1, which is this one, negative 4. The x sub 2 is negative 4, and the x sub 1 is 2. 2 minus a negative 4, minus a negative 4 is 2. Minus a negative 4 is plus 4. 2 plus 4 is 6. So minus a negative 4 is plus the opposite of negative 4. 4 plus 2 is what it comes out to. Negative 4 minus 2 is plus a negative 2. That's negative 6. 6 divided by negative 6 is negative 1. That's the answer there. For this one, fx equals 2x squared. If x is equal to negative 1, you put negative 1 in for x. The 2 is not going to come in here and get squared. Only this is getting squared. Let's keep going. Essentially, 2 is 2. This quantity, negative 1 squared, is negative 1 times negative 1 is 1. 1 times 2 is 2. We're done here as well. All right, very good. They want this in slope-intercept, write this in slope-intercept form. What do you say you take this right here, subtract 3x on each side, or add a negative 3x on each side, might be better, means the same thing. 6y is 6y, add a negative 3x on each side, divide by 6 on each side, y equals, well, you got a plus right here, so it's going to distribute. It's negative 3 over 6 times x. It's 10 over 6. 10 over 6 reduces to 5 over 3. And negative 3 over 6 is negative a half x. And, 2 times 5 is 10. 2 times 3 is 6. The 2's cancel. There it is. It looks like y equals mx plus b. The m is negative a half, not negative a half x, just negative a half. The m is negative a half x, the x is x, and the 5/3 is the b. And there you go. They want you to graph that. Basically, you could take this a bunch of ways, guys. I would take that right there, divide by 5 on each side. Y equals the 5 distributes, as you've seen how the distribution works. 10 divided by 5 is 2. This is the equation. The original equation given to you was 5y equals 2x minus 10. 5y equals 2x minus 10. Kind of in standard form, this is slope-intercept form. T-chart. Put a 0 in here. Get a -2. Put a 5 in here. The 5's cancel. You got 2 minus 2 is 0. 2 points determine a line. I guess we luck out in a sense. -1, -2. That is the y-intercept. 1, 2, 3, 4, 5. This is the x-intercept. And again, that's not the best drawing in the world, guys. I can't draw this too well, but. And there it is. For chapter 13, they're talking about if they give you this, solve this using the addition method to actually get this. Well, let's look at what we've done so far, so I can maybe erase some of this stuff, give myself a little bit more room, and we can take it from there. All right, so what we have here is, see, just make sure these are on the mark. We've got chapter 10 type stuff. The number 1, m is -1. Number 2, the answer is 2, as we have. 3, y equals -1/2 x plus 5/3. That's working. The graph of 4 is the same as this. Absolutely. So we're doing good there. And let me see here, guys. That's 3. Let's go to chapter 13. And chapter 13, we try to get some answers here. 1, 2, 3, 4. How that's all going to play out. All right, so let's do that. Forgive me, guys. It should be more than that. For some reason, they 1, 2, 3. Yeah, right. That was 10. 1, 2, 3, and then the other guy's got 1, 2, 3, 4, 5. Yeah, there should be five questions pertaining to chapter 13. So let's just get to that. See a number of things we can probably say here. This is number 1. Let's talk about it. Try to give myself a little bit of room with some of the manipulations that are going to be happening. All right, guys, there's number 1 from chapter 13. I'll try to bring everything else from chapter 13 in there as well. You have it ready right here for us, I guess you could say. And let's see how we're going to do it. Well, they're saying a number of things, guys, and talk about problem number 1 from the chapter 13 part of the final exam review. And again, the film is part B right now. They want you to use the addition method to solve this. Well, there's a lot to get rid of here, guys. There's a 4H here, a 5H here, a 7K here, a 5K here. They're not too good looking to deal with. 7 times 5 is 35. I can shoot for each one of these being 35. One of them being a -35, the other one being a +35, and then solving for H. That'll work. Or I can look to solve the H's. 4 times 5 is 20. 20h here, negative 20h there, or vice versa. Tell you what I'm going to do. Let me try to eliminate the h's. Let me multiply the bottom one by negative 5. If I multiply this bottom one by negative 5, I get negative 20h plus negative 25k plus negative 125. So the bottom one is going to be this bottom equation all the way across, I'm going to multiply by negative 5. I can do that on each side of the equation, and it's still an equation. Negative 20h multiplied by negative 5 all the way across, guys. Here, let me multiply by a positive 4. Why? Because I get a positive 20h, and you know where I'm going to go with that. Positive 4 128 right here. Sounds good. Let's add them together. That's out of there. You wanted it to be happening like that. Add these two. Add these two. K equals 1. If K equals 1, you can plug K equals 1 into either one of these equations. It doesn't really matter. This one looks a little easier to look at. 4h plus 5k equals 25. Don't know what h is. Do know that k is equal to 1, and we'll take it from there. Add a negative 5 on each side. Divide by 4 on each side. You got it. You've got h comma k. H comes before k. Might as well put it in that order. You got 5 comma 1. And that's the addition method for problem number 1. For problem number 2, they want you to solve it either method, any method actually. I tell you, you can get a little innovative with some of this stuff if you want. I mean, you got 2d equals 1.25 p plus 1. D equals 4.4. 0.35p. I got an idea, guys. I mean, it's not, you don't always see a set of equations looking like this or having this basic look to them, but so what? What do you say if 2d is equal to all of this? What do you say you double each side here and have the same 2d expressed in a different manner? So I'm going to multiply by 2 on each side. $2d is all that, and 2d is all this. Well, that's good, because all this is equal to all that. And that's a way to go. That's perhaps a pretty efficient way to go. There's a lot we can say here, I guess. Minus 0.7 pi, minus 0.7 p is plus a negative 0.7 p. Let me add 0.7 p on each side. That's out of there. This is a 1. This and this is 1.95p. We're certainly not done. but this is a good move to make. It's a good place to be. Subtract 1 on each side. Subtract 1 on each side. Got this. Yeah, let's keep going. If you got it down to here, take divide by 1.95, divide by 1.95. This divided by this, I think it comes out to 4. P equals 4. If P equals 4, I think you're pretty set. Take this particular part of the set that you, of the system that you got there. You know, to find D comma P, if P equals 4, why don't you put it right here? D is going to be equal to 4.4 minus 0.35 times P, which is 4. 0.35 times 4 is 1.4. So you got 4.4 minus 1.4. 4.4 minus 1.4. 4.4 minus 1.4 is D. 4.4 minus 1.4 is D, and 4.4 minus 1.4 is 3. P is 4. Sounds good to me. 3 comma 4, depending on how they like to express some of this stuff, you guys. Not looking too bad. Again, not a traditional way, whatever the traditional way is, I guess, to look at this stuff, but not a common way to look at trying to solve something like this. Doesn't matter too much. As long as you know that two entities are equal to one another, as long as you know that two entities are equal to some other entity, then they're equal to one another. As long as two quantities, as long as each of two quantities is equal to a particular quantity, then those two quantities are equal to one another. So, and that's some of the argument there to proceed with when you do this. So what was said here, absolutely. So for chapter 13, as we're talking about it, guys, we said H, for number 1, H equals 5, K equals 1. For 2, and that's the one we're looking at right now, D equals 3 and P equals 4. D equals 3 and P equals 4. So that's good. Problem 3, 4, 5, also from chapter 13. Let's take a look at that right now. So 3, 4, 5, they're saying, solve using your graphics calculator and find the point of intersection. Make a rough sketch of the lines, round to hundredths when necessary, depending upon the calculator. Depending upon the calculator you are using, the answers may vary slightly. Let's just solve these for problems 3 and 4, rather, how they have that. Let's just solve these, you know, as we know how to solve them. And we can use the determinant method, we can use the substitution method, we can use the elimination method. Let's write 3 and 4 down. Let's get a rough graph of what's going on, where they intersect, and let's just verify that it's true by going into doing the solutions, either by the elimination method or by the addition method. So let's start with 3 and 4 and then kind of take it from there. Um, all right. I mean, let's get some looks at this thing. Let's see what's making some sense to us at least. For number 3, obviously they want you to solve this thing. This one's already in slope-intercept form, so that's pretty much of interest. Tell you what I'm going to do. We've got this. That's fine. We know this one right here. We already got it in slope-intercept form, so we can kind of take a look at it. Let's take 2y minus 5 equals 3x. Let's add 5 on each side. Let's divide by 2 on each side, do the appropriate distributions and stuff. And y is going to be 3 halves x plus 5 halves. So here's one of the equations of the line. And, here's the second one in slope-intercept form. We'll call this guy 2. We'll call this guy 1. 2 equations, 1 and 2 in slope-intercept form. If you were going to actually look at that and just try to graph, for this one right here, do a T-chart and start plugging in some points. Do a T-chart, start plugging in some points for the first one. Put a 0 in there and get 7. Put a 3.5 in there and get a 0. 2 points determine a line, so. We got 3.5 and 0. 1, 2, 3, 4. 3.5 is right here, and you got a 0 right there. 1, 2, 3, 4, 5, 6, 7. 0, 7. Makes sense to me. It's looking like that. The other guy is the 2. Put a T-chart here. Put a 0 right here and put a 0 right here and you get 5 halves, which is 2.5. Some of these are easier to look at than others, I guess. Put a 1 right here. 1 times 3 halves is 3 halves. 3 halves and 5 halves is 8 halves, which is 4. 0 and 2.5. 0 and 2.5, and 1 and 4. Again, it's not going to be any kind of work of art, but right here we're looking at it. you know, like 2.5 and 4.5 or something, or not quite sure, but it's looking something like that. Well, I can tell you what, we can do a number of things here. If we come back to the original 2, let me get this out of here. Maybe it's more confusing than helpful, the 1 right there. Why don't you just say, if I know what x is, it'll spit out a y value for me. In the meantime, wherever I see a y down here, let me put this. Negative 2x plus 7. So on the bottom over there, the 2y minus 5, the y is negative 2x plus 7. Y is negative 2x plus 7. 5. Yeah, I mean, that's the way it is. Let's see what we got here. Distribute the 2. (14 minus 5 is 9. Add positive 4x on each side. Divide by 7 on each side. Well, yeah, the numbers were kind of... We saw the point of intersection is somewhere around 1, but over a little bit, and that makes sense. This is 1 2/7. That's the exact answer. There's no round off there. That's an actual fraction. And from there, I can go as accurately as I want from the fractions that I have. Then I plug 9/7, which is x, in right here for y. Y equals negative 2 times x, which is negative 2 times 9/7, plus 7. Negative 18/7 plus 7. Yeah, that's a rough one. What you got here when you actually do it is, you can do a lot of things here. 7 is the same as 49/7. Notice I'm trying to get a common denominator with both of these. 7 goes into 49 7 times. There we go. Negative 18 and positive 49 is negative 18 and positive 49 is positive 31. It's 31/7. Y equals sounds good to me. X equals 9/7 and y equals 31/7. 31/7 is, I don't know, it's close to 4.5, and this one's a little more than 1. Notice 1, 2, 3, 4, it's a little more than 4, just like 31/7 is a little more than 4 for that height, and over here is a little more than 1. And that's consistent with what we got going on here, guys, regarding this stuff right here. So that's looking good. Those are exact answers, actually. There's no round off on that one. Now, if you want to round off, if you get it to here, if you want to round off, okay, I think they're asking here, make a rough sketch of the lines. Make a rough sketch of the lines, round to hundreds when necessary. Okay. Well, 9 divided by 7, and we'll round it to hundreds. .2857, 1.2857 rounds to 1.29. .31 divided by 7 is 4.42857. 4.4 4.428 rounds to 4.43. Yeah, you can write that x comma y. You can, a whole bunch of stuff here, guys. X comma y is 1.29. X comma y is 1.29, comma 4.43, et cetera, et cetera. We're fine. Let's just double check that. Make sure we're all on the same page, guys. Right. For number 3, x equals 1.29 and y equals 4.43. Absolutely. Sounds good. Keep going. Okay. Number 4, they're kind of playing the same game. Let's see how it comes out. Maybe it's a little easier to look at. If it's not, then we'll deal with it. We've got kind of a standard form here, right here. And we've got another standard form here, right here. Let's take a look at these. Let's attack this thing and find out how it actually works out. Add a negative 7x on each side, and y is going to be equal to negative 7x plus negative 6. This is actually slope-intercept form. Pretty easy way to go there. With this right here, minus 2y is plus a negative 2y. Add a negative 3x on each side. Divide by negative 2 on each side carefully. Negative 3 divided by negative 2 is just positive 3/2. Negative 10 divided by negative 2 is positive 5. So divide by negative 2 on each side and get down to here. Here is this line right here written from standard form to slope-intercept form. This is this line right here. This is this line right here written from standard form to slope-intercept form. From here, you can say, okay, let's try to get some kind of a feeling for what's going on here. You can put a 0 in here in the t-chart and get a negative 6. Let me put, let's see how this works out. These aren't the easiest numbers to deal with. Let me put a negative 1 in here just for the heck of it. Negative 1 times negative 7 is positive 7. Positive 7 and negative 6 is 1. Well, 2 points determine a line. I don't know, we'll see where that's going to go. Let's do a t-chart over here and see where that's going to go. Put a 0 in here and get 5. Put, you can do a lot of things here, I guess. Put a 2 in here. The 2's cancel, 3 and 5 is 8. Well, okay. I mean, there's a good amount of stuff here, guys. What we're looking at is, for this one right here, we're looking at the graph of this thing. 0, comma, negative 6, 0, comma, negative 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. 0, comma, negative 6, negative 1, comma, 1. Right, negative 1, comma, 1. Okay. Well, relatively steep. I don't know that I drew this the best way, but that's what we're talking about right here, far left-hand side, right here. This left-hand equation, here's what it's looking like. So for the left-hand equation, it's a negative slope. It's sloping upward to the left, Here, it's a positive slope. It's going to slope upward to the right at 0, comma 5. 1, 2, 3, 4, 5. That's 0, comma 5 and 2, comma 8. 1, 2, 6, 7, 8. Okay, as luck would have it, I drew this horribly. I don't know that it went that way. And that might not be the right graph on that, but let me just see here. Now, this graph is off, obviously, guys. I maybe got a bad start on it, but we're looking at the graph being somewhere more negative than negative 1 and being somewhere up to a positive 2 or something, like negative 1, you know, as an answer here. So let me see exactly where you'd go with this. Guys, I'm sorry. I think I'm going to just graph this again. I'm going to try to graph something a little bit stronger than that. Let's try it again. Y equals negative 7x plus negative 6. You put in all the points. You got 0, comma, negative 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. 0, comma, negative 6, and you got negative 1, comma 1. I do not like the way this is graphing, but okay, let's try to make some sense out of it. We got that. The other one is 0, comma 5. 2, 3, 4, 5. And 2, comma 8, 6, 7, 8. Okay, not a great drawing here, but basically we're in the second quadrant to get an answer here. Let's look at it and say, okay, well, how do you want to do this? Well, let's look at the originals as they are. Let's use the elimination method. You know, let's take this original right here. Let's take this original right here. Let's write them down and let's see what we can say. It's any commentary we can make on that. 7x plus 1y equals negative 6. 7x plus 1y equals negative 6. Right, as simple as that. 7x plus 1y equals negative 6. 3x plus a negative 2y equals negative 10. There they are. You got this guy, you got this guy, you got what we had over there. I'll tell you what I'm going to do. Let me multiply this top equation by 2 all the way across. You see why I'm going to, you can probably see why I'm doing that right now. As I'm looking at it, why don't you take these two new equations and add them together. 14x and 3x is 17x. 2 and negative 2, forgive me, 14x and 3x is 17x. 2y and negative 2y is 0. This and this, negative 12 and negative 10 is negative 22. x is negative 22 over 17. True. True. You know, y is going to be, you solve for what, you know, I tell you what, at that point coming over here or coming over here will give me, I can plug into either, I mean, this one converted to slope-intercept form spits out the y value. This one converted to slope-intercept form will spit out the y value. It's probably a little easier to look at. Y equals 3/2 x plus 5. Y equals 3/2 x plus 5. X is negative 22 over 17. Negative 22 over 17. The 2 cancels into here, you got negative 11. Three times negative 11 is negative 33. 1 times 17 is 17. Here's 5. 5 is the same as 17 over 17 times 5, multiplied by a special 1. Y is equal to negative 33 17ths plus, convert this to something over 17. 5 is the same as 5 times 17 over 17, which is 85. 5 times 17 is 85. 17 is 17. Y is equal to, add these two together, you got 52. This right here is a little more than 3. This right here is about 1 1/3. So the ballpark answer on these guys is that, you know, this is the answer at the end of the day, you guys. I mean, let me. See what we got here, guys. You could say at the end of the day that x is negative 22 over 17, which is close to negative 1.33. This right here is 52 over 17. And that's not bad. I mean, you get these are the exact answers, actually. They're the exact answers. You want to round them to hundreds, to hundredths, rather. I'm all fine with that. These are exact, though. Let's make it really, really clear. These are exact. This is about negative 1.33. This is about positive 3.1 something. Positive 3.1 something, negative 1.3 something. Something like that. This is a little more than 5 in magnitude. This is a little more than 5, and this is a little more than 1.3, or about 1.3 in magnitude. As we look at it, $1.2941. So negative 1.2941 right here. The other one is 52 divided by 17, 3.0588. The 5 goes up to a 6 because there's 88 right next to it, 3.0588, so that's 3.06. And again, you can write it as an ordered pair. You can write it like this. Negative 1.9 and 3.06. Negative 1.29 and 3.06. You got it. Looking pretty good. Let's do 5, and that'll take us through this part that I wanted to do. So let's see what we got. Okay. Still in the chapter 13 content on that. The last problem I wanted to do related to it was, in fact, if I could find it, there it is. Okay. So they're telling us, eliminate W and solve for T if I give you these two equations. They want you to eliminate W and solve for T. So we've kind of been down this path before in earlier work that we've done. Guys, still chapter 13 content here. So D equals BW over R, and W equals D over RT. Eliminate W and solve for T. Well, the best way to eliminate W is that wherever you see a W, remember that W equals D over RT. So right in place of W, put D over RT. So D equals B times W. And we said W is D over RT. And it is from, now we're not done. But it is from here that we proceed. It is from here that we proceed. Now they want us to solve for T. If you got that right there, what do you say you just multiply by T on each side? So if you got D equals B D over T, what do you say you just multiply by T on each side? If you do the same thing on each side, it's still an equation. TD equals BD. At that point, let's see here. What does it say? So, yeah, right. I'm sorry. I was about to solve for the wrong thing. You can solve for a lot of things, I guess. But the best thing to do is solve for what they're asking you to solve, right? And that's on me. That's my fault. TD equals BD. If you divide by D on each side, very, very odd. I almost think, I hope I didn't do this wrong. It's coming out pretty easily. Almost too good to be true kind of thing. T is equal to B, according to this logic. T equals B. That makes, am I missing something here? Because they're doing something here that doesn't make any sense to me. But I'm sure I'm missing something. This can't be. Let me, No, this is, okay, there's not, there seems to be something not right here. The way either I've done this wrong, which can certainly happen. I do that a lot. Let's just make sure if I did or not. They're saying here they're saying for number 5 on page 4, the bottom of page 4, still in chapter 13 review content. Of course, we're in this film for the review content, part B of it. It's the last problem of it. It's page 4 for part B, and it's problem number 5, and they're saying eliminate W and solve for T. They're saying that D equals B times W over R, and W equals D over RT. Solve for T. I simply said take D over RT. Yeah, I could have done this wrong, and I did do it wrong actually. Let's try that again. Try that again. And now I just erased something that was correct. It's one of those things, I guess. Let's see here. Let's start this over, guys. Wherever you see a W, put D over RT in place of W. D over RT over R. That means D, we said what the W was. Wherever you see a W, put D over RT. Wherever you see a W right here, put D over RT. W is D over RT, so we got all this. D equals B, D over RT over R. Dividing by R, it's a very interesting point in its own right. How rigorous do we want to be with this? Is it true B is really B over 1? B times D is BD. RT is on the bottom. R is the same as R over 1. A fraction divided by another fraction is the first fraction, the one that's being divided, left alone, multiplied by the reciprocal of the second fraction doing the dividing, which is BD over, which is BD, just multiply across. BD times 1 is BD. RT times R is R squared T. D is equal to this. D is equal to BD R squared over T. Solve for T. Multiply by T on each side. Divide by D on each side. Or multiply by 1 over D. We're not done. We're not done. We're here. For some reason, I seem to remember this thing looking a little different, even in the answer key. I gotta think it's this, guys. I got nothing if it doesn't go beyond that. We got t equals b over r squared. Yeah, okay, the way they wrote it, okay, that's kind of threw me too. They've got it written, okay. They got t equals b over r sub 2. They got t equals b over r sub 2. That's not true. They mean to say squared. Okay, we all make mistakes. I made one just now. We corrected it. So it's going to happen sometimes. Let's do our best with this, guys, but it should be this. It should be this, not that. And not what I did earlier, which was my mistake. T equals b over r squared. Looking good. All right, that completes part B. We just got parts C and D to do, and then we're done with all of this content. Okay, thank you all for your time.